Greetings, everybody. Welcome back to our third installment of trigonometric integrals. So let's kind of continue our discussion of what we do when the powers of our products on sines and cosines happen to both be even. And so what we have in this example, suppose somebody just walks up to us on the street and hands us the integral of sine to the fourth times cosine to the sixth. What can we do about that? Well, we can kind of start out doing something similar to what we did before. Since both powers are even, we can rewrite that with our power reduction formula as sine squared and cosine squared cubed dx. And so with our cosine cubed, well, now we can apply our power reduction formula. So what happens there? Now we're getting a 1/2 minus 1/2 cosine of 2x squared and a 1/2 plus 1/2 cosine of 2x cubed dx. And so kind of our first power reduction formula, things get a little bit better because our powers are reducing. We started off with a power of 4 and 6. Now we're down to powers of 2 and 3. So things are getting a little bit better. And then just kind of like what we did in the previous video, we can expand these expressions. Now, if we do, they're going to get long, they're going to get complicated, but let's take a look at what the result is after we expand those. So kind of before we do that, the last thing that we can do is maybe take out our extra powers of 1/2 that are floating around in here. So we have a 1/2 squared, so we've got a 1/4 from the first factor, a 1/8 from the second factor, so 1/4 times 1/8 is going to give us 1/32 times our integral of 1 minus cosine of 2x squared, a 1 plus cosine of 2x cubed dx. And now from here, it makes it a little easier to expand things. So let's kind of look at what the result looks like from there. And so in expanding this out, what we're seeing is that we end up with essentially a polynomial in cosine of 2x. We've got 1 plus our cosine of 2x, cosine squared of 2x, cosine cubed of 2x, cosine to the fourth of 2x, and cosine to the fifth of 2x. And for each one of these terms, now we can kind of develop a strategy for each one of those and kind of solve this problem recursively. So kind of what we're seeing here, if we look at just the first couple of terms, so with our 1 plus cosine of 2x, that one we can just integrate without a problem. So that one is no big deal. We can do that. We know that with our cosine squared, so our cosine squared term, now that one we can use our usual old power reduction formula, and that will simplify that problem. So we end up with probably something involving a cosine of 4x to the first power, and we can integrate from there. For our cosine cubed, so now when we've got a cosine cubed, for this one now we've got an odd power of cosine, and just like this one, so we've got odd powers of cosine. And so for each one of those cases, we have the techniques from a previous video where one of our powers was odd and that we could do a u substitution and and take that root. So both, whenever we have odd powers of cosine, we can remedy those. So now the only thing that we really need to deal with is our cosine to the fourth. So what do we do with this thing? So with our cosine to the fourth of 2x, if we were just integrating that, let's kind of separate that one out. If we were doing the integral of the cosine to the fourth of 2x dx, well, we can do a similar thing that we did before. Here's where the recursion kind of starts to come into play. Well, we're seeing this as cosine squared of 2x squared dx. And what happens from that? Well, we do our power reduction formula. So this gives us a 1/2 plus a 1/2 cosine of 4x raised to the second power dx. So now we've gone from a fourth power down to a first power. Well, when we square it, we'll have a second power of cosine of 4x. And so if we bring that to the outside, we can take out our 1/2, square that, so we have a 1/4. And so we have a 1 plus 2 cosine of 4x plus cosine squared of 4x dx. And so again, kind of what happens in this case, well, we're kind of back to our something that we can just do a direct integration from. And then we have another cosine squared of 4x. Well, one more power reduction formula for that. And if we do a power reduction formula for that, what happens? So we've got the integral of the cosine squared of 4x dx. Well, we can do this as just apply our power reduction formula. Again, so we have a 1/2, a 1/2 plus a 1/2 cosine of, now double the argument, 8x dx. And so with this one, we have our 1/2 x plus 1/16 sine of 8x plus our arbitrary constant. And so kind of unraveling all of this, we are able to then expand all of our terms. We may have to do each kind of one of them kind of piecemeal, but for all of our powers, we are able to simplify each one and eventually kind of chop down the tree a piece at a time, and we eventually are able to integrate those formulas. And so kind of what happens when we have even powers of sine and cosine. So kind of maybe to recap this a little bit, if we've got something like sine to the 2n power of x and cosine to the 2m power of x dx, that the idea was that we make them sine squared of x to the n power, cosine squared of x to the m power, apply power reduction formulas so that we end up with a 1/2 minus 1/2 cosine of 2x to the n, 1/2 plus 1/2 cosine of 2x to the m power dx. And from there, this will expand and give us a polynomial in cosine of 2x. At that point, once we expand and we have this polynomial in cosine, then we are able to either continue power reduction formulas. So continue power reduction for even powers. And for odd powers, we use our previous technique. And so in those instances, we are able to come up with methods for simplifying sine and cosine to even powers. It's a little more messy, it's a little more involved, but we have a strategy that we can implement to eventually chop the tree down and get to the answer that we're really looking for. So I hope this has kind of been informative and kind of descriptive as far as what we can do in this case. And so this finishes two of our cases for powers of sine and cosine. So stay tuned for the next videos and we'll start tackling secant and tangent. And I will see you guys then.